Hello. At the end of the previous video, we looked at this intro into water, so let's run through this rather quickly. Water is important in terms of biology because living organisms are predominantly water. So the chemistry of water has a lot to do with the chemistry of life. We talked about how water is a polar molecule, meaning that it has electrical charges at either end, and then this polarity is due to that oxygen to hydrogen covalent bond, having a polar covalent bond in there. Look at the idea in this hydrogen to oxygen covalent bond. Oxygen has a stronger pull for the electrons than the hydrogens. The electrons are skewed up towards the oxygen end, and so the distribution of charges on the water molecule is such that you have a weak negative charge on the oxygen end due to the collection of these electrons at the oxygen end, and a weak positive charge on the hydrogen end. I told you need to be familiar with that distribution of the charges, the polar nature of water. Okay. Polarity causes water to be a fantastic solvent. We looked at the term solvent, solute, and solution. Water, of course, is the solvent. Solute is material dissolved in the solute is what's dissolved in the solvent. And here we're looking at something like table salt dissolving in water. The material that dissolves in water has electrical charges that interacts with the charges on the water. Okay, so and there's the diagram from your textbook. Now, something that's water soluble will have electrical charges, either polar covalent bonds or it'll be ionic. It is hydrophilic, and so charges on the solute interact with charges on the water. If it's non-water soluble, it has non-polar covalent bonds, so it does not have charges to interact with charges on the water. It is hydrophobic. Okay, and then we looked at hydrogen bonds. This polarity of water also causes water to form hydrogen bonds, in addition to being a fantastic solvent. And the hydrogen bond is a weak attraction between the positive hydrogen and, in this case in the water, a negative oxygen. Remember, you can also have a hydrogen bond that is a weak attraction between the positive hydrogen and a negative nitrogen. Okay? So in water, each water molecule is bonded to other water molecules around it. Okay? So there's a diagram from your textbook, and just a little better artwork than what had in the previous diagram. Okay, here's where we left off in the previous material. Well, that's not good. Here's where we left off in the previous material, is the fact that water has a lot of unique properties that are due to these hydrogen bonds. Let's just run through those. One of the first properties we see is that water shows tendency towards cohesion and adhesion. Cohesion, that is two of the same things sticking together. Water molecules sticking to water molecules. Adhesion, that's two different things sticking together. In this case, water molecules sticking to some other type of substance. And this counts for capillary action, and it enables water to move up through narrow tubes. And one important place where that occurs is in trees. Water is able to move to the top of very tall trees without any type of pump mechanism, because of this hydrogen bonding of water molecules to water molecules to water molecules, and hydrogen bonding of water molecules to the cellulose making up the cell walls in the tree. Okay, also you've seen this when you go to the doctor and they take a small blood sample and they put this little capillary tube on the drop of blood on the tip of your finger, and the blood moves up through that capillary tube. There's no suction involved. It's just the nature of the hydrogen bonding of the water to the surface of the glass, and water molecules bonding to water molecules. It pulls water up through that narrow tube. If the tube is wider, water does not pull up nearly as far into the tube. Another characteristic that we see due to the hydrogen bonds is surface tension of water. Hydrogen bonds tend to be concentrated in a horizontal plane on the surface of the water. The hydrogen bonds the water molecules can't bond with anything above them, so we get a horizontal concentration of hydrogen bonds. And some insects, such as these water striders, take advantage of that. Okay, another characteristic we see is high heat of vaporization. Now, the heat of vaporization is the amount of energy required to evaporate 1 gram of a substance. And so with water, in order to evaporate water, all the hydrogen bonds around a water molecule have to break in order to liberate that water molecule as vapor. Now, what this does for us is it provides evaporative cooling, because it takes a tremendous amount of heat energy to change that water from a liquid to a vapor. Okay? Another characteristic that we see is water has a very high specific heat. Specific heat is the amount of energy required to raise the temperature of a substance. Okay, and so it takes a lot more heat energy to raise the temperature of water than it does to raise the temperature of rock or metal or most other substances. And the reason it takes more heat energy is because each of these water molecules is bonded to the adjacent water molecules. So as the water absorbs heat energy, it's not just vibrating a single water molecule, but it's vibrating this entire mass of water molecules. Okay, and what high specific heat of water does for us is it stabilizes the temperature of the Earth. We've got a massive amount of water here on Earth, and it absorbs and releases large amounts of heat energy with very little temperature change. Another unique characteristic of water is the fact that ice floats. Okay, ice, that is water in the solid state, is less dense than water in the liquid state. Water is the only material that we have here on Earth that is less dense as a solid than it is as a liquid. All other materials are more dense in their solid state than they are in the liquid state. And the reason that water does this is because in the solid form, in the form of ice, each water molecule will form all 4 hydrogen bonds around itself, and that'll push the molecules further apart. And the only place you have mass is in the nuclei of these atoms. So if you push the molecules further apart, it's just more empty space. Okay, so right here it's showing water in the form of vapor, no hydrogen bonding or very little hydrogen bonding there when water is in the form of vapor. Then in the liquid state, we have hydrogen bonds forming, but they're continually forming and breaking and reforming, and that allows water molecules to move in closer together. But in solid state, this forms a crystalline structure, and when we talk about it something being a crystal, it means that the molecules are placed in very specific positions, and there's a very uniform arrangement to the molecules. Okay, let's look at let's put this in another video, so let's stop this one. Okay.